Hi children, we continue with our fourth chapter, carbon and its compounds. In the previous class, we learned the nomenclature of carbon compounds. The structure was given, you were asked to write the name of the compound. Now, we will learn how to write the structural formulae and condensed formulae of organic compounds. Name will be given, you have to write the structure. What you learned is, structure was given, you are asked to write the name. The opposite way we will do. Okay. So, there are three rules to be followed when you write the structural or condensed formulae of organic compounds. First one is carboxylic acid group. Carboxylic acid group is COOH group and aldehyde group, CHO group, always come at the terminal position of a hydrocarbon chain. Terminal position means end position only. Either on the left hand side or on the right hand side. End positions only carboxylic acid and aldehyde groups come. So, there was a question in one of the previous years board exam, name two functional groups which always come at the terminal position of a hydrocarbon chain. Two are there, carboxylic acid COOH and aldehyde group CHO. Okay, keep in mind these two groups should be written always at the end position, at the corner, end position. It can be on the left hand side or on the right hand side, but at the end position only we can write the carboxylic acid and aldehyde group. But second point, ketone, CO group, always come in the middle of the hydrocarbon chain. Ketone group always come in the middle of the hydrocarbon chain. It will not come at, because the functional group as such is CO with two bonds on either side. One bond on the left hand side, one bond on the right hand side. So, it always come in the middle of the hydrocarbon chain. Then halo group, chlorine or bromine or alcohol, it can come anywhere in the hydrocarbon chain. At any position of the hydrocarbon chain, these groups can come. Okay. So, these are the three rules that we have to keep in mind when you write the structural formulae or condensed formulae of organic compounds. Aldehyde group and carboxylic acid group always at the end position, ketone in the middle only, then halo and alcohol group anywhere in the hydrocarbon chain. Now, take your notebook, write down this, we will do it together. Write the structural and condensed formulae of the following compounds. Write the structural and condensed formulae of the following compounds. First compound is bromobutane. Bromobutane. So, to start with, please listen. When you named organic compound, we started by counting the number of carbon atom and finding the word root, meth, eth, prop, like that. Here the word root is given, but. So, what is the information that we get from this but? It shows that there are 4 carbon atoms. So, we will write 4 carbon. So, but means 4 carbon atoms are present. Now, it is ANE. ANE, showing that all the bonds are single bonds. The bonds between carbon atoms are single bonds. Now, is there any functional group present? Yes, bromo. So, write the bromine atom, Br. Bromine should be written. Now, what we have to do? The other valencies of carbon should be marked and it should be filled with hydrogen atom. So, this is the structural formulae. How will you condense it and write? CH3, first carbon, 3 hydrogens around, so CH3, second carbon, CH2, carbon, 2 hydrogens are attached to the second carbon, third carbon also 2 hydrogens are attached. What about the fourth carbon? CH2, 2 hydrogen atoms and a bromine atom, CH2. Br. So, this is the condensed formula. I hope you understood. You start with the word root, then write the required number of carbon atom, then see whether it is ANE, ENE or YNE. If it is ANE, write all the bonds, single bonds. Then the remaining valencies of carbon should be, then the functional group should be marked. After marking the functional group, all the remaining valencies should be filled in with hydrogen atom. Pentanol. Here the word root is Pent. So, write 5 carbons, it is AN, showing that all the bonds are single bonds. Am I right? 5 carbons with single bonds between them. Which is the functional group here? OL. OL stands for which functional group? Alcohol. So right, alcoholic group is OH. So everything is marked. Now what is left? Remaining valencies of carbon should be marked and it should be filled in with hydrogens. Now we will condense it and write. First carbon CH3, second carbon has 2 hydrogen CH2, third carbon also CH2, last carbon CH2OH. So this is pentanol, 5 carbon atoms with an alcoholic group. Next, ethanoic acid. Eth stands for how many carbons? 2 carbon. Eth stands for 2 carbon. Then what is it? It is eth, after it AN. AN means the bond between carbon is single bond. Bond between 2 carbons is single bond. Now what is the functional group here? Oic acid. What is oic acid functional group? COOH. So one of the carbon, we cannot write COOH again. It will make the total. If you are writing like this, what happens? The total number of carbon atom becomes 3. It is not eth now. So one of the carbon should be converted to COOH. So this is how we write the, it can be written like this also. This is COOH, condensed and written. This is the structure of COOH functional group, C double bond OH. Now everything is written. Now what is left? Valencies. First carbon has 1 valency occupied. It has 3 free valencies where you have to write the hydrogen atom. Don't write any hydrogens on this carbon which has a functional group because it's all the 4 valencies are already occupied. So what is the condensed formula? CH3COOH. This is the condensed formula, CH3COOH. This is ethanoic acid and it is commonly known as acetic acid. This is the acid which is known as acetic acid. Under weak acids you have learned this CH3COOH. Then I told you that we will be learning this in 4th chapter. Next, butanal. So write 4 carbons, but, then AN means all the bonds are single bonds. Now al stands for aldehyde group. So one of the carbon, end carbon in this chain should be converted to the aldehyde functional group CHO. So this makes the CHO functional group. Remaining valencies of carbon should be filled in with hydrogens. What is the condensed form? Now write the condensed formula for this. CH3, CH2, CH2, CHO. So this is butanal. Pentanone. Pent means 5 carbons. AN means all the bonds are single bonds. There is a functional group. On stands for ketone, and as you know, ketone always come in the middle of the chain. It doesn't mean that it should be exactly in the middle. It will not be on the end carbon. That is the meaning. It will be, the CO group will be somewhere in the middle of the chain. So I will make it. Now it is exactly at the middle, but it need not be the second carbon, third carbon or fourth carbon. They are the middle carbon atom. You can place it there. So one of the carbon in the chain is converted to the CO functional group, making the total number 5. Now the remaining valencies should be filled with hydrogens. Condensed formula is CH3, CH2, CO, CH2, CH3. So this is pentanone. This is pentanone. Next, chloroethane, an easy compound. Ethane means 2 carbon atoms with a single bond in between. What is the functional group? Chlorine, Cl. Please don't count this C as carbon. This is C of chlorine only. Now the remaining valencies should be, so making it CH3, CH2 Cl. Chloroethane. Chloroethane. Next, hexene. How many carbons? 5, 6. 6 carbons. Ene means one of the bond is a double bond. One of the bond is a double bond. All the other bonds are single bonds. There is no other functional group. So, the remaining valencies should be filled in with hydrogen. First carbon has 3 free valencies. Second carbon 2 free valencies. Look at the third carbon. 3 valencies are occupied. 1 free valency. Here also 1. So, write hydrogens. Now, condensed formula will be CH3, CH2, CH, double bond CH, CH2, CH3. This is hexene. Next, pentyne. 5 carbons, 5 carbon atoms. YNE means one of the bond is a triple bond. Okay, remaining bonds should be single bonds. Now, look at the valencies that are free. First carbon has 3 free valencies. Second carbon, all the 4 are occupied. Third one also, all the 4 valencies are occupied. Fourth one, 2 valencies. So, everywhere you will write hydrogen. After writing hydrogen, you can write the condensed form. It becomes CH3, C, triple bond C, CH2, CH3. This is pentyne. Hexanone. Hexanone, how many carbons are there? 6. Okay, hexanone. All the bonds are single bonds. After hex it is AN, so all the bonds are single bonds. Then functional group is ONE. So one of the carbons in the middle should be converted to ketone functional group. Now, do not put any hydrogens on the carbon which contain the functional group. It's all the 4 valencies are occupied already. Okay, write hydrogens on these valencies and you will get the structure as CH3, CH2, CH2, CO, CH2, CH3. So, you have to write hydrogens everywhere. I hope you will do it. Propanol. Prop means 3. Prop means 3. AN. So, all the bonds are single bonds. Al means aldehyde. So, one of the carbon should be converted to the aldehyde functional group CHO. Remaining valencies hydrogen atom. So, we write it as CH3, CH2, CHO. This is propanol. Methanoic acid. Methanoic acid. Meth means only one carbon atom. Meth means there is only one carbon atom. So, that carbon should be converted to the oic acid functional group COOH. Now, how many valencies are occupied for this? 1, 2, 3. 3 valencies are occupied. There is only one valency left. So, which atom you will put there? Carbon you cannot, because that will make the total number of carbon atom more than 1. So, it is hydrogen only. It forms bond with a hydrogen atom. So, CHCOH. This is methanoic acid, commonly known as formic acid. Methanol. Methanol. There is only one carbon. Al means aldehyde. So, convert this single carbon into aldehyde functional group. Its 3 valencies are occupied, 2 with oxygen, 1 with hydrogen. So, only one valency free where you can write hydrogen. You cannot write carbon there. Here this compound has only one carbon, meth. So, you cannot write carbon here. So, we will write hydrogen. HCHO. This is methanol, the simplest aldehyde. Methanol. Okay. Next, bromopentane. Pent means 5. Pent means 5. So, write 5 carbon atoms. Single bonds in between, pentane. So, single bonds. There is a functional group, bromine. Now the remaining valencies should be filled with hydrogens. Now condense it and write CH3, CH2, 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 Br. This is bromopentane. Butanone. But means 4 carbons. All butanone, AN, so all the bonds are single bonds. One of the carbon should be converted to on, ketone functional group, and the remaining carbons it becomes CH3, CH2, CO, CH3. This is butanone. CH3, CH2, CO, CH3, butanone. Hexanal. Hexanal. Hex means 6 carbon atoms you write. AN. So all the bonds here are single bonds. Al is aldehyde functional group. It should come at the corner end only. So make it CHO. Then CH. So this is hexanal. This is the condensed formula. I hope it is clear to you how to write the structural formula and condensed formula of carbon compounds. You have to practice more questions. That's all. Thank you, children.